Well, welcome to another video from the Goat Shed. It's September 30th today. It's a lovely day. It's around 18 degrees Celsius, which is roughly 64 degrees Fahrenheit. And here we go with another stepper video. Yes, I know we've done a few, but here we go. This is a Williams stepper. Now, like the Gottlieb, the Williams have their own little idiosyncrasies. The main difference here, you really only need about 5 tools to effectively do one of these. The 3 nut drivers and the 2 different size Phillips head screwdrivers. Yes, Williams largely on their mechanical parts used Phillips head screws for some reason. Not sure why that was, but they did. So this is a ball count unit out of a 1967 Williams Apollo. Here are the major components out of it. We have the spider, contact spider, the 2 springs here, springs, the 2 coils, the 2 coil stops, the 2 plungers, the escapement wheel itself, the drive pull there on the drive arm assembly. It's actually fixed to it, very much similar to a Gottlieb. And what they call the reset or index arm. Now, if this was a different type of stepper, if this was a single step reset stepper, it would have what they call an escapement pull, which fits on this shaft here. We'll be doing one of those on a credit unit over the next week or so. So bear in mind there are 3 types of steppers. There's continuous rotation, like a 0 to 9 unit. There's total reset, like this one, which is a ball count unit. There's single step reset, which is like a bonus unit. And they actually do have a total reset and a single reset stepper. Now, I think Williams used those in some of their baseball games. Not sure if they used them in any pinball games. So what we're going to do today, we're going to put this one back together, piece by piece. Here we have that unit there. That's a detent. That latches in the index arm. Drive pull. The only one adjustment on a Williams stepper is this thrust screw here with a nut on it. Now, we'll show you how that works later. You don't often have to move them, but it's a very, very simple adjustment to do. Very clever, very well engineered, these steppers. So we'll start assembling this and we'll go through it step by step what we do. Right, so there's the drive pull, drive arm, put back on. As you can see, it gets held on by a circlip on that pivot post. You need to lightly lubricate that. They do get stuck there a bit, and the drive pull has to obviously move up and down quite freely. The index arm here is designed so that it will hold the drive pull up and out of the road while a reset is done. And this little bit here we mentioned is the detent. That locks the pulls into place till you do the first stroke and it releases to drive. Now this particular stepper drives in a clockwise direction. This piece here, like we did a video on the Gottlieb the other day with the 0 stop where it's sort of up here, this piece is moulded into the frame and that pin there hits it. So that's the home position. It's not adjustable and it doesn't need to be adjusted. So what I've got to do now, if this was a single step reset stepper, this collar wouldn't be there. You wouldn't have that collar. What would happen is the arm, another arm fits over there, which is like a reset pull, but Williams call that an escapement pull, which makes a lot of sense to me. But we don't have one on this particular stepper. So we'll just carry on reassembling and talk about it bit by bit. Okay, it's all back together now. So if we watch carefully, that's the index arm here we were looking at before, or the reset arm. Remember I mentioned about this detent or spring-loaded lock? What that does, that holds the index arm and the drive pull up out of the road. When I operate the index arm, the drive pull, the index arm or reset arm will fall down and the drive pull's ready to drive. Now earlier on we were talking about an adjustment, which is this here. This one looks to be pretty well perfect, so if you operate the plunger on the reset, see that? It's falling back into place against the face of the tooth. There's a little bit of a gap there, which is fine. But if that was in the wrong spot, if that wheel was, say, too far forward, that would allow the wheel to step backwards before it went forwards. So that's the only adjustment. Brilliant engineering from Williams, in my opinion. Now, these two posts here, the post here and this post, they actually have a nut on the back. So like all good pinball mechanics, we should check all screws for tightness, and that's what you need the 3/8 nut driver for. 3/8 nut driver will do the nuts on the back of those posts, while the 7/16 one will do the nut that goes on the back of the escapement wheel that holds it in place, and the 11/32 one is to undo the nuts on the brackets, these brackets here, to get them off. Now this bracket here is loose, this one. The reason that is, there's a screw missing out of it, and the reason that screw is missing out of it there is because an earth strap does go onto that in the wiring harness, so you've got to remember to put that on or you'll have no ball count lights. Alright, so this is cleaned up pretty good, so essentially we're ready to put this back in the machine now and test it. So that'll be good to go. So let's get busy and go and put it in the machine, and we'll have to clean up the... this has got a printed circuit type board in it, so we'll show you that. So what Williams did in a lot of cases, they used a printed circuit type board instead of the rivets. You can see that they did that on the 0-9 unit as well. The reason that they did this was to eliminate the fact that there was wires joining things across, like a common wire going across the back of the circuit board, so there's nothing on there, and it minimised the amount of wires that they needed. Once again, quite brilliant design work. We've occasionally had on Gottlieb games where the links that are soldered together on the back of those brass rivets can break off, and in fact I had one actually yesterday on one of my own games. It wouldn't match, and the problem was that link was actually broken just behind the board, so I had to take the board out and fix it up. Not that that's a big deal, but that was just the way Williams decided to do things. So that's pretty grungy, that. You can clearly see where that's been wearing in there for a long time. So I'm going to give that as best clean up as I can. It won't end up perfect, but away we go. So I'll get busy now and I'll clean that up. Well, there it is. Came up a little bit better than what I thought. So we'll start to put this back together now, and I'll apply some PBR grease to that. I've already dremeled the spider contact finger contacts, so put it together now and we'll see how we go. So now we've got the stepper all mounted back in. Nuts are all done up, ready to go. We've got that all important earth strap there screwed in. Just now a matter of got to solder the wires back on. But all in all, Williams steppers are pretty easy to do. And this one works really well now, so let's watch it reset. It really was struggling before. There it goes, look at that. So step up and reset. Beautiful. Okay, so if anyone has any questions, please write them in the comments. We're happy to try and help you. That's what we're here for. So we hope you enjoyed our video, and once again we would remind you to like and subscribe to our channels, but most importantly like our videos and give us any comments, positive or negative. We're happy to receive them. So this has been another Goat Shed presentation.